Welcome back to Algebra 1, Quadratics Part 2. This is page 311 to 314 if you're in my class. And we are solving quadratic equations by extracting the roots. In my opinion, this is the easiest method if it is able to be used. So this should be a fairly straightforward lesson to you guys compared to what else we're going to do. So the basic things you need to know is isolate the squared term. That's the letter with the squared on it. You want it by itself. Okay, take the square of both sides, simplify, and check. All right, and this goes fairly quickly. If we look at problem number 2 that we have, the x squared's already by itself, the number's on the other side. So check, we've got the isolated term. All right, then it says take the square root of each side. So square root. The square root of a letter squared is always just a letter, so I'm going to get x. And then the square root of 100 is 10. However, you have to do a positive and negative because a negative times a negative makes a positive. So all of these answers will have plus or minus before your answer. And that's pretty much it. Now, if I was going to check that and I put 10, right here, 10 squared is 100. Does 100 equal 100? Yes, I'm good, okay? So let's move on. 12 is a little bit harder. X squared is not by itself. All right, 4 is being multiplied, so we must divide first. Okay, so I have x squared equals 25 over 4, and 4 doesn't go in there wholly, so I'm going to leave it as a fraction. Then take the square of both sides. Okay, the square root of x squared is x. The square root of 25 over 4, when you have a radical around a fraction, do the top separate and the bottom separate. Square root of 25 is 5. The square root of 4 is 2. And that is my answer. If I put 5 halves in there and squared it and multiplied it by 4, I would get 25. So if I did 5 halves squared, that would make 5 times 5, that would make this. And then if I multiplied that by 4, I'd put it over 1. The 4's cancel out, and I would get 25, and 25 equals 25. Okay? So moving on to 17 and 20, these are a little bit harder and probably more like what you would really see in the class. They pumped you up with quite a few easy ones. The first 14 I think are pretty simple. 17, first of all, it's not isolated. Everything's not on the sides that it needs to be. So first of all, I'm going to move this number over with 23. It is a negative 4, so I add 4. And I get 3x squared equals 27. Then I need to divide by 3 to get x squared by itself. And that's going to give me x squared equals 9. And then I take my square roots. X equals plus or minus 3. Okay, the square root of 9, if you can use your calculator if you don't know those square roots. It's 3, so if I went back into my original problem and I put a 3 there, 3 squared is 9. 9 times 3 is 27. 27 minus the 4 is 23. So we are checked there. Okay. And the last one I'm going to show you on this video is 20, which is your stopping point. You're going through 20. So this, by definition of the way these are on the page, this should be about as most difficult as it gets. So if you can do this, then the rest of the page will be simple. Alright, so I got an x squared here and an x squared there. Since this one's positive, I'm going to move them all over there. So this is a negative 2x squared, so I need to add it to both sides. That way it cancels on this side, and I get 10x squared equals 5. Okay, then I got to divide by 10 so that I can get x squared by itself. And I get x squared equals 5 over 10. Okay, that reduces to 1/2. It's easier to work with smaller numbers. So I really have x squared equals 1/2. Okay, Now, we take the roots of this. This is why we learned radicals the last 2 weeks, is because we're going to have to work with radicals. The square root of x squared is x. And we know we got a plus and minus here. And I cannot take the square roots of those things because they're not perfect squares, but I cannot leave a fraction in the bottom, or a radical in the bottom of a fraction. So I need to make this a square. So I multiply the bottom to get 4, but whatever I do the bottom, I have to do the top. So I make this 2/4, which still is 1/2, okay? And I can pull this root out. The square root of 4 is 2, but it's on the bottom of the fraction here, so it stays on the bottom of the fraction here. And the radical 2, this part, stays right here because we can have a radical in the top, we just can't have one in the bottom. And then we leave that alone. If you wanted to input that in your calculator and do 1/2 radical 2 squared, you could put that in your calculator, times it by 8, and then put it over here and see if you get the same thing. But the point is, after you get the hang of it and you check a couple, you'll be fine. No need to show your checking on there. Hope you, I wouldn't say enjoy this lesson, but be thankful for it, because the ones to come aren't going to be as nice. Thanks for watching. Have a good rest of your day. God bless.